This is a lecture from OpenTuition. To benefit from the lecture, you should download the free lecture notes from opentuition.com.
In this chapter, we look at some more up-to-date IT or digital technology approaches which businesses can use. And the first one you'll have almost certainly studied before is big data. The idea of a vast database, usually holding a lot of historical information about, for example, customer behavior. It was large supermarkets which began this, where with loyalty cards, whenever you make a purchase, the supermarket is recording exactly what you bought, when you bought it, and the like. And by building up several years' worth of this information, then it hopes to be able to gain insights into customer behavior, which you can use to its advantage. Generally speaking, big data is characterized by the 3 V's. In other words, the velocity with which new data is accumulated is very large indeed. So if you think about all the supermarkets in your country, all the transactions which are taking place on a daily basis, or even by minute, then the system holding the big data has to be capable of receiving this data and processing it very, very quickly. Secondly, there's a variety of data. Now you might just think, and indeed it was the case, that in supermarkets all they would really have recorded would be what you bought, how many units, what you paid for it, the date and the time. But now they can combine that with more information, like what was the weather like at a time, because very often consumption is linked to weather. They are also beginning to use techniques such as facial recognition, so that when you walk into a supermarket, assuming you've been there before, obviously, it identifies you and can track you going around the supermarket. It can see which cabinets, which shelves that you kind of paused at, and if you pause for a long time in front of a particular shelf, but maybe don't buy, then it probably knows that you're interested in that product, and then maybe it could be thinking of sending you some sort of special offer. Of course, big data is not just limited to supermarkets. Think of the huge amount of data that your mobile phone company can hold. Who you call, how long you were on the call with them for. It'll record your geographical position very, very accurately, even if you're not making calls. And this has been used in many court cases now to tie up the location of a suspect to the location of a crime. So there's numerical data, there's graphical data, there's geographical data, there's voice data, there's pictures, and on Facebook that if you appear on someone else's post, then there's a good chance that you will be tagged, that it will recognize who you are. And then volume. It speaks for itself. If you're recording all of this information as a huge volume of information, it doesn't matter very much to us, except that in an IT basis you need to have special techniques to deal with the huge volume, the huge variety, and the huge velocity at which data keeps coming in relentlessly to the system. A final characteristic is sometimes called veracity. It's not an inherent characteristic, but it's one that you want to be present. You want to have faith that the data being held is true. Because if you are then using this deposit of data, this big data, to make decisions, and there are errors in the data, if it has misrecognized someone, for example, then of course you will be making decisions based on false data. After the big data has been accumulated, it will go into a process of data analytics, sometimes called data mining. And it's like gold mining. In gold mining, you go through, tons and tons and tons and tons of just kind of earth, and occasionally you find a nugget of information or a nugget of gold, that is going to be extremely valuable. Similarly, in big data, you have to process through lots and lots and lots of really dull data that's not going to yield anything of any use, but occasionally there will be this nugget of information which is going to be very precious in increasing profitability or efficiency. Data analytics are sometimes divided into three types. First of all, there is descriptive. For example, describing how the purchases of a particular product may be changed during the week or maybe are correlated to weather information. There's diagnostic. Diagnostic is where you ask questions about certain events. So you can say, if somebody buys A, is this in any way correlated with the purchases of B? And that's an investigation, if you like, the diagnostic. And then based on both of these, really, there are predictive analytics. Once you have got this correlation maybe between purchasing habits and the weather, if you know that at the weekend the weather is going to be kind of 20 degrees centigrade, then you can make some sort of prediction, some sort of forecast of what demand might be for certain sorts of food, whether people believe it's kind of going to be good enough weather for a barbecue, and we ought to stock up on typical barbecue foods. Big data, of course, is accompanied by dangers, and the dangers are roughly this list here. First of all, it's an extremely costly operation to maintain and to use the big data to perform the data mining, and we have to be careful that it's money well spent. There are huge privacy issues. If supermarket and your purchasing habits may be bad enough, but the mobile phone knowing where you are all the time, the kind of information people seem to voluntarily release on Facebook and Instagram and so on. And then, you think the information is safe, but then suddenly somebody hacks into a database and credit card numbers are released, and then it's a basis for fraudulent transactions. In response to these privacy concerns, many countries have brought in very strict regulations governing the use of personal data, and if companies breach these regulations, they're liable to come in for very severe penalties from the authorities. As I said, we have to be careful that the information is true, that it has veracity. If it's inaccurate information, we are bound to be making inaccurate analyses and forecasts. And finally, we have to be aware of our reputational potential reputational damage. If it's thought that we were collecting information that we shouldn't be, holding on to information we shouldn't be, releasing or using information that we shouldn't be, then our reputation is likely to suffer. Just think of the Facebook scandal, when it was thought to be releasing information that was going to be used potentially for electoral purposes, and how that really got the company into a lot of trouble and really damaged its reputation considerably, at least for a while. Next, we can look at a very new technology called blockchain technology. And as blockchain technology, which also opens the way to cryptocurrencies, such as bitcoins. But let's not worry about the cryptocurrency. Let's just think what's meant by a blockchain type of technology. And the essence of a blockchain technology is twofold. First of all, once data is written to the blockchain, it cannot be changed. It can be added to, but it can't be changed. So you have this great gift, if you like, of an indelible historical record of everything that's happened, let's say a share or a coin indeed. And secondly, the information is held in a very distributed, very dispersed way over maybe thousands of separate computers. But let's say what we're going to do is we're going to look at the history of a building. Now, in most countries, the ownership of a building is held in some sort of government property register. And that's really the only proof of who owns what in terms of apartments, houses, land. And it's obviously susceptible to fraud. If the name of the property owner is changed by a corrupt official, then it could be very difficult indeed to work back and ascertain who used to be or who was a proper owner. So let's say in block 1 we write down who is the legal owner. And then if the ownership changes, or if the house is extended, or there's planning permission given, what we then do is we have to add that, and that will be in block 2. So the original owner's information is still in block 1, and maybe what we have in block 2 is information that the property was sold by owner 1 and is now owned by owner 2. And what happens, the heart of this here, we didn't get into it too much, but there's a technique of hashing, which means that all the information here, no matter how long, is converted into a 256, usually 256 character code. It goes through a mathematical process. It comes out with these. They look random, and you can't undo them. So I couldn't go from these 256 characters back to the block. So it comes forward, and that is stored there. So along with the transaction information in block 2, there is this hash information of block 1. And then when we go to the next block, maybe the ownership changes a third time, all of this information, including the hash, goes into another hash, and that's kind of included in there. So what you have is this kind of carrying forward of something which is this special mathematical, almost cryptographic code, which means that if you were to change the ownership here, then it's not going to kind of reconcile properly with the hashes and so on. So it's essentially indelible. And this is what happens with bitcoins. Bitcoins, you've got the whole history of what's happened, that Bitcoin, who has owned it, where it's been spent, where it's been earned, and this builds up this complete history of the Bitcoin. The owners are kept anonymous. They have a particular code, so you can't trace back to the person who owned it, but you know a kind of unique code number of the person who owned it, and they have a way into that then can prove that they are that owner. So that's the first thing. Just remember an indelible history of all transactions. You can add to the blocks, you can keep chaining bits on, but you can't change what was there already. The second aspect, as I said, is that this is held, the chain is held in many, many thousands of computers. And what they do when another block is added on, they verify that everything seems to be reconciling, all the hashes are in order, and the like. If one of them disagrees, if something goes wrong with the processing in that computer, then basically a vote is taken of all the other computers. So I, as a fraudster, couldn't go and just change the records in one place, even if I changed them quite comprehensively, because all of these other computers will be holding another version of the truth, and I would be the one out of line, and my version would be regarded as being non-true. So again, it is very immune from targeting a particular computer and corrupting the records within that computer. And blockchain is now used for property, it's used for share transactions, it can be used for personnel transactions, it can be used, of course, for coin transactions, of which Bitcoin is only one particular type. The cloud. What is the cloud? Well, it used to be that if you had a little network, so here we have for users. They could be joined together in a little local area network. But each of them would be, using Word. Each of them would be using Excel. And let's say, for the sake of argument, that this is an engineering company, and each of them is using a computer-aided design program. And they, of course, can communicate with each other by email and so on. And that, if you like, was a traditional way of setting up an office. Disadvantages. First of all, what happens if the version of Word you're using changes? You want everyone really to be on the same version to make sure the documents are compatible. It means getting everyone to update their version of Word or Excel or the CAD program at the same time. And of course, there's always a few people who can't be bothered. They're quite happy with their old version and they don't want to learn any new tricks. Secondly, it's expensive. We need 4 versions of Word, 4 versions of Excel, 4 versions of the computer-aided design, and of course in a proper office you'd be dealing with hundreds of these versions, and we want to make sure they're up to date and compatible and so on. The third, most people wouldn't be using maybe Word at the same time, or wouldn't be using the computer-aided design program at the same time. Most of us in the office go through a number of different tasks. I do a bit of spreadsheet work, and then maybe draft a report in Word, and then maybe in the afternoon or something, I'm involved in doing some kind of graphics work, something of that sort. But these computers, they all have to be kind of powerful enough, let's say, to run the CAD program. CAD is a particularly processing intensive system. It needs a very powerful computer to run graphics applications. So all of these computers have to be kind of top notch, so that everyone can run their CAD program for 10 minutes a day if that's what they want to do. And it's not a very efficient use of all that processing time sitting there just in case somebody needs it. So what has happened now is that instead of everyone having their own copy of Word and a computer-aided design program and Excel and so on, a copy of Word, Excel and a computer-aided design program resides in the cloud computer or the cloud computers. The cloud is very often, or the cloud machinery is very often run by a third party, a very large computer organization, maybe something like Hewlett-Packard or Microsoft, basically rents you time and space on this remote cloud computer. And what happens if I'm doing some word processing as user 1? I do not have a copy of Word on my computer, but what I see is like the Word screen. Word is really up here, but I see the screen. And when I type stuff into my keyboard here, then that interfaces with Word up there. So all of these people could be using Word, but there's really only the one copy of Word, and they are all using the processing power of the cloud computers. Now, Word doesn't demand huge processing power, but think of computer-aided design. It does require very fast, powerful computers, and what happens is if user 1 wants to use computer-aided design, well, then the cloud computer will again act as the interface. It's powerful enough to do that. And if user 2 also wants to use a computer-aided design, this computer, if you like, it's almost as though it can expand. There's a bank of computers, and if one computer is kind of getting occupied already with processing, other resources can be switched into that. So it provides very, very kind of flexible remote processing, and it means if each of these here, these could be called a lean client. It means they can be very, in a way, non-powerful, cheap computers, because they're not acting as an awful lot more than maybe a terminal, like a kind of interface. The real power is needed in one place up here. And of course, if the version of Word changes, it's only going to be changed in one place. So everybody is dealing with exactly the same software. And the output is pretty much guaranteed to be compatible. Other IT technologies. Well, we have 3D printing or additive manufacturing. What happens in additive manufacturing is it can be done with plastics or metal now. It's very common with metal. But you build up layer by layer. It's almost like an inkjet printer, but instead of spraying ink on a page, it's spraying metal powder, which can then be fused, or plastic pellets, which are then fused. So first of all, it might spray that sort of a shape. A flat kind of oval type shape. And then it'll go over it again, and on top of that, it will spray another oval, but slightly bigger, but on top. Next time, it might put on 2 little bits of the metal or the plastic, and it'll keep doing that for a little while, 2 little bits, 2 little bits, and so on. So every time it passes over like passing over the paper on an inkjet, it puts just a little tiny thin spray on, and then it can kind of be bringing it back together. And there's your last one. So it is possible by clever adding of pieces of metal, pieces of plastic, to actually create, if you like, a ring. And it's not like creating a ring by taking a solid coin and drilling a piece out. That is subtractive process. This is an additive process. It can be linked to computer-aided design. So once you've designed a component on computer-aided design software, it can be made more or less instantly by the 3D or additive printing machinery. It means that you can make prototypes extremely cheaply. They're made automatically. It means that you can produce spare parts very, very quickly if the main production of the spare parts is no more. It means you can produce unique items, and it's got particular interesting uses in medicine, where, for example, let's say I had some disease and I needed a new jaw. Then from the x-rays and scans, it can take that information and it can create an absolutely precise shape for a piece of bone, a joint, something to patch a hole in someone's head. And this is remarkable. It is going to make a lot of production of quite intricate items and low volume items in particular very much cheaper and very much faster. Business automation, well, just think of factories. If you go onto Google and put in robots, which is a form of business automation, if you put in automated warehouses, you will find on sites like YouTube then all sorts of fascinating film clips of computers doing their stuff on making cars or making machinery. You see the trolleys sailing around the warehouse as though they were in a kind of dance. Artificial intelligence. Well, artificial intelligence coming on leaps and bounds. You may know that particularly Google has a subsidiary which has proven very, very good at playing chess and playing Go. It was taught the rules of the games, but it was not taught any other techniques. Basically what it did, it played thousands and thousands of games of Go, say, against itself. And from successful and unsuccessful strategies, it essentially built up a skill. It learned as it went along. And artificial intelligence beginning to kind of creep in much more to accounting as well. Auditors are taking an interest in it. Auditors often are looking for what might be regarded as unusual or suspicious transactions. And artificial intelligence is being increasingly used to help them identify transactions which seem to be, out of character, unusual, unexpected. And then the auditors can go and look at those transactions in some more detail. The Internet of Things, all sorts of devices talking to each other, basically. So it would be quite easy to, in a way, connect a shelf in a warehouse. So when units were taken off that and the shelf gets lighter and lighter and lighter, when it gets, to a certain minimum weight, then the system knows, I better send an order off to the supplier because we're soon going to be out of stock. We can have it connected to the heating in the factory, the lighting in the factory, all sorts of different pieces of technology connected together. Of course, you hope they're not going to be hacked into, but that's a matter of security. Data visualization. You've all probably used Excel to draw graphs. It's got a very powerful kind of graphical output. You can produce all sorts of bar charts, pie charts, three-dimensional charts, and so on. The great thing about visualizing data like that is very often it's easier to assimilate it, to understand it, and secondly, it's usually more memorable, and thirdly, you can often see relationships between bits of the data that aren't plain from tabular figures. Increasingly, data visualization is itself animated. You're not just looking at a static graph. So let's see if I can bring up, just to show a couple of graphs that we would have here. If I can find the right page. There we go. So there we have a graph, and as you see, when I turn my pen over it, this is some sort of geographical map of a volcano. It's giving down here where the cursor is, it's giving the coordinates. Here's another form of animation, very simple, interactive, but when you drag your mouse over the country, it comes up with the country's name and the population and so on. And that's kind of I think easier to understand than a great list going down the side of the graph, showing all the countries in alphabetical order. And then we have these sort of graphs here, where by drawing your mouse or pen over them here, it's giving kind of precise information rather than having to kind of read it off the side here. It's giving precise readings of the values of the curve. Mobile computing. Mobile computing, like a salesperson going out and taking an order and uploading it directly. Like being able to take with you a kind of mobile catalogue. It's used by airline pilots instead of great big manuals of safety instructions. They take devices like iPads and so on, and they can go through checklists on that. They can very quickly find by search facilities particular pages, particular components in the aircraft that they're going to be interested in. And it's phones, it's tablets, it's the communication by Wi-Fi or communication by 4G or 5G has really made this come along. The technology is working together. Well, an example would be Rolls-Royce. Rolls-Royce produces aero engines, jet engines. And what Rolls-Royce does, it has effectively within its more advanced aero engines, it has lots of sensors, if you like. Let's just think of them listening to or recording vibration, recording temperatures, recording pressures within the engine. And as the airliner is, let's say, flying over the Atlantic, this information is sent back to Rolls-Royce in Derby. So we have a kind of, it's processed a little bit on the plane, and then it is uploaded, if you like, to Rolls-Royce's computers in Derby. And then there, Rolls-Royce effectively uses artificial intelligence techniques to identify where an engine might be going a little bit wrong and where it needs to be serviced within maybe the next month. So it begins to detect maybe it's vibrating a little bit too much at certain revs. It's beginning to detect that maybe the pressure isn't just as it should be. And the great thing about this is that it anticipates when servicing is needed, and then the aircraft can be taken out of service in a kind of controlled way, the engine repaired and taken back, rather than the aircraft being full of 200 people and the pilot then discovering some red light coming up and saying, I'm sorry, there's an engine fault, we all have to get off, which causes, the airlines huge amounts of disruption. And finally, social media. I think we're all pretty aware of the power of social media. Companies now extremely edgy, if you like, about comments made about them on Facebook or on Twitter. They seem to react more quickly to a criticism made on Twitter than they do to a polite email sent to their customer relations department, because of course they are aware that once a tweet is made, it can be retweeted many times, it can grow viral, as they say, and suddenly huge amounts of damage are worked very quickly on the company's reputation.